Today we're going to have a look at data binding with JAXB and JAX or S as an example of data externalization. So you should be on the Moodle course page. The CRN is 45620, Distributed Systems. At this stage you should already have looked at the screencasts on key attributes of distributed systems and interprocess communication models. Now if you scroll down, under the section Introductions, Definitions and Basic Concepts, you should see a lab here, XML JSON data binding with JAXB. So what I want you to do is click on that, download the lab, and open it up. And we should have a file here called ds data binding lab.zip. I want you to unpack that, and that should create a directory called ds data binding lab. So if we go on in there, you have a PDF document which are notes to help you through this lab and describe the steps that we need to go through. I'll be going through these here anyway in the screencast, but you should read the document as well. So what's the lab about? Well, really, it's the notion of data externalization or marshalling. Is the conversion of a whole graph of objects into some format suitable for transmission between running processes on possibly the same machine or even different machines. And there are lots of different standards out there in finance, things like XBRL, electronic data interchange for banks. We have different medical formats for sending between computer programs. This is structured information. And also in biology, specifically in bioinformatics, there's a whole wealth of interchange formats. So in the context of interprocess communication, we're not really looking at these specific things. We're looking at more general ideas. And the kind of ideas we're looking at really fall into three different categories. We have binary data formats, such as the common data representation format used by the Corba standard. And these binary formats have the benefits of being, first of all, highly structured. They're also highly compact, and they are highly efficient. However, the issue with them is the level of difficulty associated with scoping and developing these binary standards, and the difficulty then in implementing them in a heterogeneous distributed system, which we know to be the norm. Another option is a semi-compiled or optimized semi-compiled format. For example, Java bytecodes. These are also called serialized forms, and they are used extensively in both Java and in C#. These are highly efficient and flexible, but they only work in a homogeneous distributed system. For example, if it's a wholly J2E application or .NET platform, it'll work fine, i.e. it's got to be .NET centric or Java centric in order for that serialization to work. Another level up, okay, and away from the binary, at the top, if you like, are Unicode formats. Now, Unicode is a standard 8-bit and 16-bit Unicode for ASCII and Cyrillic, and then the full-blown, multitude of different language types in the world. And we have different formats for these too. You might be familiar with semi-structured things like, tab delimited or comma CSV delimited formats. They're very, very flaky and weak. They break down because they're not that well structured or organized. However, the XML standard and the JSON standard are much, much better approaches. These are, however, quite verbose. They're least efficient in terms of moving information around. But because of the ubiquity of Unicode and pretty much universal support among operating systems and programming languages, it's actually an ideal mechanism for creating technologies that can act as glueware for basically piecing together heterogeneous distributed systems. So in particular, we see that JSON and XML formats combine both the flexibility and portability of Unicode formats with a very fine degree of structure and control. So what we're going to do in this lab is use a basic XML schema document as a data definition language. And from this, we're going to generate a suite of Java objects, a whole graph of objects from the schema. And after that, we're going to convert the Java objects to and from XML and to and from JSON. And we're going to see how these, both XML and JSON formats, can be used as an externalization mechanism. So the first thing we'll do, folks, is we're going to open up the file po.xsd. po.xsd is our XML schema. So I'm going to open up this. I'm on a Mac here, so I'm going to open up this in TextMate. And what we should see here, folks, if we scroll up the top, is that the XML schema definition is itself an XML document. Okay, now an XML schema is to an XML document what a relational schema is to a suite of tables. In other words, it's a data definition language. The XML schema defines what a valid instance of an XML document is. An XML document that is syntactically correct is called well-formed. Okay, a valid XML document must be both well-formed and be fully compliant with either a document type definition or an XML schema. Now, if we look at the XML schema, we will notice a couple of things here. First of all, you see this namespace here, XSD, and that is the standard used to refer to the XML schema definition. And we see here that the namespace XSD maps to this, w3c.org/2001/XML schema. 2001 is the year that the XML schema standard was actually published. There does not have to be anything at these URLs. These are analogous to namespaces in C# or C++ or Java packages. The main thing is that they are unique. Now we're creating another namespace here called GMIT, and this refers to ourselves, sw.gmit.ie/ds for distributed systems. This is a default namespace, okay, so the namespace prefixed with a GMIT. The target namespace for any XML document that is implementing this schema should be the same here. It should be sw.gmit.ie/ds. Element form default is qualified, means that there must be qualified elements with these namespaces in order to be valid. So we're defining basically, we're defining a schema, a sequence of values here for what we call a purchase order. And the kind of things we're going to be looking for here are ship to information, bill to information, SKU, a stock kept unit, addresses, order numbers, and that type of thing. So first of all, we look here, we are defining an element, and the element name is comment, and the type is an XSD string. The XML schema definition allows us to specify three things: a sequence, multiplicity, and the data types of elements. Sequence, what things follow, what elements follow, what other elements. Multiplicity, how many of them, is it one-to-one, one-to-many? And finally, the data type, i.e. is it a string, an int, a long, or whatever. So in this case, we're saying a comment must be a string. Second, we're creating a thing here called a purchase order. The type in this case now is gmit.purchaseorder. And gmit.purchaseorder is a complex type. If we scroll down here, we'll actually see it. gmit.purchaseorder consists of what? It's a sequence of what? An element called ship to, an element called bill to, an element called items. Ship to is a type GMIT address, which is defined up above. Bill to is also a type GMIT address. And finally, items is a type GMIT items. We're also defining two attributes for a purchase order. One is an order number, which is a type GMIT order number, and it is required, it is mandatory, it must be there. And second is the order date, which is a type XSD, in other words, the XML schema standards understanding specification of what a date object is. So let's scroll up and have a look at these different types here. First of all, we have a few things here. We need this before we go looking at the date. I have a simple type, and the type is called country. And I have a restriction, which is basically an enum or an enumeration. In other words, a set of all the valid countries for this purchase order. Now I've just put in a few here, otherwise we'll get unwieldy. But the notion here is country must be taken, the value for country, from this list here. So we've got Ireland, UK, US, France, Spain, Italy, Germany, Russia, and China. The type order number, the simple type, that is an attribute of the root element of purchase order. And order number is, again, it's a type. What type? It's a string, and we're putting a restriction on it here. We're saying, and this is the equivalent of this is a regular expression. It must consist of 5 numbers, 0 through to 9, followed by a hyphen, followed by 4 letters in uppercase between A and Z. We have an SKU, a stock kept unit, and in this case here, it's basically 3 digits or 3 letters in a row. The complex type, as opposed to a simple type, will basically be compiled, we'll see in a minute, into a class. And we'll see how this works. So an address consists of what? Some annotation, documentation here as to what an address object is, and then a sequence of what? A sequence of name, street, city, county, and country, all of which are strings except the last one here, country, which is the enum, which we just looked at above. We're going to use this complex type for both ship to and bill to. The complex type, another one, is items, and items contains a sequence of what? Of items that occurs a minimum of 0 and a maximum of an unbounded number of times. What this means is an ordinal number must have 0 or many items in it. Perhaps that should be 1 or many. Anyway, and the item itself is a complex type that consists of a product name, which is a string, a quantity, which is what? It's a positive integer with a minimum value of 100 and a minimum value of 1 and a maximum value of 100. A price, which is a decimal, a ship date, which is a date, and a part number, which is a GMIT stop-kept unit that we have mentioned up above there. Now notice the way that this is done here. This is effectively going to result in an inner class. The way this is done, it could have been done as two different complex types. This is the way it is for this lab, and that's fine. We'll get around some of the issues that may be created from this. One other thing you might note here is that the decimal does not map to a float. We're going to use wrapper types like java.math.bigdecimal to handle these. Okay, once you've got the purchase order in, I want you to kick open a command prompt, and I want you to go to the directory in which you downloaded the documents. I'll explain what each of these documents is as we meet them. So in my case, it's in downloads. I'm going to go to CD to downloads, and I'm going to CD into the data binding lab. I'm going to do an ls minus L. If you're on DOS, type in dir. Okay, and what we're going to do now is we're going to compile this XSD, the XML schema. And what we're going to do is we're going to use the XJC, is the XML Java compiler. So this is going to convert that schema into Java. -npa is don't create the package information. And what schema do I want to use? I want to use po.xsd. The JAXB framework, of which the XJC compiler is a part, is now shipped as part of the core standard Java SDK. JAXB is the Java architecture for XML binding. So I want you to hit enter, and it's going to parse a schema, and it's going to generate, given the namespaces that we used in our document, it's going to generate the classes address, country, items, object factory, and purchase order. All of the address, country, items obviously refer to the complex type in the schema. Object factory is just a class that allows us to manufacture instances of purchase order, and we can see that they're all nicely packaged. So what I'd like you to do is to open up those documents in the those documents here in TextPad or TextMate. Open up these classes in TextMate. Okay. And what we see, folks, is a load of generated stuff. So look at purchase order first of all. Purchase order has been auto-generated, and effectively what we have here, folks, are we're using composition here. We've protected address ship to, protected address bill to, protected items, protected string order number, and protected date is Gregorian calendar date. We'll have a look at that in a minute. Now notice, folks, here that these are just getter setter methods. So effectively, a purchase order acts as a container for two address objects, a ship to and a bill to. An items object. What we don't have, folks, we'll see is the setter methods for the actual item itself, which if you look at in a minute, it's actually of type items here, protected items. Now, I did mention it would be an inner class. Have a quick look at Object Factory here. Object Factory, folks, is just a mechanism for creating an instance of a purchase order. Okay. Items itself, folks, represents the list of items. So we have a list, java.util.list of items.item types. So these effectively now, folks, are, as I said, an inner class inside the items class. That's because of the way the schema was written. Okay, and now look, we have a get method, but what you won't see is a set method. And it's explained in the documentation here that's auto-generated. The accessor method returns a reference to the live list, not a snapshot. In other words, folks, it's not returning a copy, it's actually returning the actual array list of items. So if you want to add items, okay, to a purchase order, you call items.getItem, and that returns a list, and you add them to the list. And naturally enough, that will add them to the array list, the live list itself. Okay, now there's a couple of things we need to do in terms of making this work, but just notice for the minute that we're using extensively annotations in order to document things. This is the way JAXB and JAX RS in the RESTful Services API works as well. Have a look at country. This was the enumeration, and if we see, it's just a bog standard Java enum that's generated as. Finally, if we look at address, you will see that the address object itself is simply a bean class with name, street, city, county, country, and various getter setter methods for those instance variables that were defined in the po.xst. Okay, now I'm going to close, we'll go file close all for the minute. And I'm going to go back, and what I want you to do now, folks, is I want you to open up a purchase order on its own. And because purchase order is the root, there's one thing missing from the class here, and it is an annotation that needs to be applied to it. So we need to put, it's documented here in the PDF document, so I might copy and paste it so I won't make a mistake. We need to import this here. This is required, but is not actually added by the compiler. So I want to go to import that JAVX, that XML that bind to the XML root element, and then I want to add that at annotation here, XML root element, down here as the first statement really in the class, and I want you to save that. Okay, now what I'd like everyone to do is to go up to the project directory itself, and you'll see, folks, that we've got some libraries here, and I've got two different versions of or ways to two client applications, if you like, or things that use that generated graph of objects. One is in Java, the other is in Python. But if we just open these again and just have a look at them, and I will go through the Java one and the Python one, you see is actually very, very simple. It's only a proof of concept. First of all, as I said, we've got the type of date we're using is actually a XML Gregorian calendar. In order to do that, folks, you have to use a bit of a convoluted way of doing it. I create a standard java.util.gregorian calendar, pass it a new date with the current time in nanoseconds, and then pass basically our java.util Gregorian date to the JAXB's XML Gregorian calendar. Then what I do is the following. I create a context based on my namespace. Okay, I call the generated object factory that was generated by the compiler. I ask the object factory to manufacture a purchase order. I set the order number. I set the order date. I create an address called ship to, and I set that as my bill to and my ship to on the purchase order. So in other words, the person that's being shipped to is also the person that's paying for the order. I set the country to the enumeration, country.Ireland. I now, and this is a bit, it doesn't look great, but it's the way you got to do it, unfortunately. I create a new items object, set that as for my purchase order. I ask then my items object to give me the items list, and this is the live list I was talking about. I then create an item and I add it to my list. Notice, folks, the integers are big decimal, as I say, and the decimals, the floats are big decimal. That's just the way we have to map the XSD decimal type to Java. I create a second item and I add that, and then I'm going to do the following, folks. Marshal the information to XML format first of all. So I'm creating basically a marshalling object from my context. Okay, I'm going to say marshal it to basically JAXB XML format and format it, in other words normalize it, put in the spaces and line breaks, and send it out to a file called orders.xml, and also for our own convenience output it to the screen. Now I'm going to do the same thing in JSON format. This time I'm going to use, this is not part of JAXB, this is what the other APIs, the other three are for. We're going to use Jersey to basically, Apache Jersey to do the same in JSON. Okay, so in other words, give me a JSON JAXB context, a mapping between JSON or JAXB and Jersey, and give me a JSON marshaller and basically write it out into JSON format and write it out to the screen. And then we're going to do the reverse, the unmarshalling of it. I'm going to unmarshal the XML by asking my context to give me an unmarshaller. And I'm going to do the following. I'm going to go, look, Mr. JAXB, unmarshal this file, the stuff in order.xml, that XML, into a purchase order for me. And to prove that it works, we're going to print out the order number. Then we're going to ask JSON to do the same thing, or Jersey. We're going to say, Jersey, give me a JSON unmarshaller, and do what? Unmarshal order.json into a purchase order, and again, prove that it works by outputting that information. Okay, now let's compile this information first to make sure that it works. So in order to do that, folks, I'm going to do the following. I'm going to go Java-C minus what? Hyphen CP is class path. I'm going to use dot is the current directory. I want definitely the current directory on my class path. Colon, if you're on Windows, you need a semicolon. Dot / what? I want to add in the Jersey to compile it. Put in a colon. We delimit these elements on Unix with a colon, on Windows with a semicolon. Dot / what was the next library is JAX and all. That's the JSON library. And I also need the ASM.jar. And I'm going to do the following. This will work on Linux. I have 2 steps in the notes for you if you're on Windows. I'm going to do the following. I'm going to do a star, and I'm basically going to open a bracket and go find. It's a Linux find. I'm going to go find what? Dot / star. I'm going to pipe that into grep search for .java. So in other words, this is effectively going to recursively compile everything from the current directory all the way down. It's a very useful thing when you're building big projects. So let's execute that, and that works fine. That's everything compiled. And finally, I get to run it then. So I'm going to do the following. I'm going to be quite lazy in this. I'm just going to put in the name of the file I want to execute is JAXB example, JAXB PO example. And instead of Java-C, I'm just going to use Java, launch a Java virtual machine. And what we see, folks, is it's working fine. Here is the purchase order in XML format. And if you look at it again, our document prologue here, folks, is UTF encoding, ASCII encoding. Okay, the root element is purchase order. We see all the ship to information. We see all the bill to information. We see the items. Okay, the ship date and all that kind of thing. And we see the exact same thing then in JSON format here. And to prove that they both work, we both XML unmarshal and JSON unmarshal the same information. Now just to prove that the Python script works as well, we have a little script here which is very, very simple that just outputs it just reads the JSON, and that was the point, just to show that we could do it. If any are Python gurus and you want to put meat on the bones of this stuff, I'd be grateful, and I'll include it. I'll put it up on Moodle. So that's all we're doing here. It's basically outputting the JSON file and then outputting the value associated with build to and name. So I'm going to execute that now by just going py to Python. What is the name of it? It is called jb.py. I'm going to execute that, and that works too. Okay, folks. I'd like you just to consider if any we're thinking of perhaps maybe doing something in some other language like Perl, C Sharp, C++, JavaScript even, and just show basically how to yourself how information can be passed around and parsed in unambiguously in different programming languages by externalizing the information as text.